Next is example 6. We are given a function y 3x to the power of 4 minus 4x cubed plus 1. Find the relative extremum points using, please take note that here we need to use a second derivative test, and if exist. As a first step, we need to find the critical points of this function y. For that, we will start with writing y function 3x to the power of 4 minus 4x cubed plus 1. We need to find the first derivative of this function, which is dy over dx, where the derivative will be 12x to the power of 3 minus 12x to the power of 2. Next, we will equate this first derivative to be equivalent to 0. In order to do this, function 12x to the power of 3 minus 12x to the power of 2 need to be equated to 0. At this point of time, the first derivative of the function y has been equated to 0, and in order to solve this, we are able to factorize 12x square, and we will have x minus 1 as the next factor. So when we solve this, 12x square is equated to 0 and x minus 1 is equated to 0. From here we will have the first x to be 0 and the second x to be 1. So these are the critical numbers obtained for this question. So please take note that we have two critical numbers here. Let us continue finding the corresponding y values for every x obtained in earlier step. For that, the first x obtained was x equals to 0, and finding the corresponding y will be simply substituting 0 into the function here, where we will be having 3 times 0 to the power of 4 minus 4 times 0 to the power of 3 plus 1. This will give us a y value 1. And for the next critical number, which was x equals to 1, the calculation of y will be 3 times 1 to the power of 4 minus 4 times 1 to the power of 3 plus 1, where this is equivalent to 0. So this going to give us the coordinate where the pair of x 0 and y1 is coordinate 0, 1, and x1, y0 as the other coordinate. So these two coordinates are now the stationary points for this question. Now we are in step 2, where we will be doing second derivative test for the function given in the question. For that, we start with having the derivative, the first derivative of the function, which is 12x cubed minus 12x squared. For this first derivative, we continue to find the second derivative, which is d2y over dx squared. This will give us 36x squared minus 24x. And we test this function for the first critical number that we have obtained, which is x equals to 0. So for x equals to 0, the d2y over dx square value is 36 times 0 square minus 24 times 0, which is equivalent to 0. Remember earlier, when second derivative test value equivalent to 0, we say that this function has no relative extremum. Relative extremum doesn't exist at x equals to 0. Now we continue the process for the second critical number, which is x equals to 1. For x equals to 1, the second derivative value d2y over dx square is 36 times 1 square minus 24 times 1, which is 12. And we observe this value is positive. So when this value is positive, we can do further conclusion about the stationary point, which involves critical number 1. Now let us conclude in step 3 the nature of the coordinates obtained earlier, where for x equals to 1, we have the second derivative value to be 12, which is positive. So when the second derivative value is positive number, we will see the coordinate involved, which is 1, 0, as a minimum point. So for this question, we have only one minimum point, and the other coordinate 0, 1 doesn't create or doesn't have any relative extremum on it.